So another example. X squared plus 13 equals 4x. Step 1 becomes important here. So get into standard form by subtracting 4x to both sides. X squared, remember standard form has the squared term first, the regular term next, and then the constant last. So I'll put minus 4x next, and then plus 13 equals 0. This is standard form. So we're good now. All we have to do is find A, B, and C, and then the discriminant, and we're done. A, B, and C. A is 1, B is negative 4, C is 13. So the discriminant, which is B squared minus 4AC, equals negative 4 times negative 4, which is 16, minus 4 times A, again it's 1, times C, which is 13. 4 times 13 is 52. So 16 minus 52, and that equals negative 36. This is a negative number. Yeah, duh. Since this was a negative number, what does it say about our discriminant? Our discriminant was negative, less than 0. So there are 2 conjugate imaginary roots. So that's our answer. 2 conjugate imaginary roots. I'll write that. 2 conjugate imaginary roots. And that's the nature of our roots. It describes what kind of roots we'll have. So, I mean, it's pretty simple. I'm just going to give you problems that you guys can do. It's going to be a short video. Yeah. You do. So after I write down the problem, you can pause it and then do it on your own, and then I'll show you the answer. Oh, it's a little bit different. Square root of 3 x squared minus 4 root 3 equals 0. Okay, pause it here and work on your own. I'm just going to finish it now. We need to get this into standard form. There's an x squared term. There is no x term. So that must mean the coefficient of the x term is 0. So I'm going to rewrite this into standard form by doing this. Root 3x squared, we want the x squared term first, plus 0x, clever, minus 4 root 3, that's our constant term, equals 0. Now we can write down our a, b's, and c's. A, B, and C. I'm going to color code this because it might be a little confusing. So A, B, and C. C is negative 4/3. B is 0. And we can see that now. And A is square root of 3. So let's write those down. Square root of 3, 0, negative 4 root 3. Now that we found A, B, and C, we can find our discriminant. B squared minus 4AC. So B squared, 0 squared is 0. Minus 4 times square root of 3 times negative 4 square root of 3. Whoops. So what do we have? Negative 4 times negative 4. I mean, this is 0, so we can ignore it. Negative 4 times negative 4 is 16, positive. Square root of 3 times the square root of 3 is the same thing as square root of 3 squared. So that becomes just 3. I don't even really have to stop right now. I mean, finish right now. Because I know this is positive. And that's all we're trying to look for. Positive, 0, or negative. That's all we need. And this is positive. So we go back to our little gray box. When the discriminant is greater than 0, when it's positive, then we have two different real roots. Two different real roots. That's real talk. That doesn't, I don't know. I don't know what I'm saying. Simple. Just the coefficients look funny. That's the only thing that's different. So another you do. 1/2 x squared plus 3x minus 12 equals 0. This is already in standard form. Pause it now, and then we can work on it, or you can work on it on your own, and I'll work it out right now. A, B, and C is what we need to find, since it's already in standard form. A is 1/2, B is 3, C is negative 12. So b squared minus 4ac is the discriminant, and will tell us the nature of our roots. 9, the nature of our family, like the past, the descendants, our roots. That's where our roots are. That was a joke. 9 minus 4 times a, 1/2, times c, negative 12, which is 9 minus 4 times 12 divided by 2 is 6, so it would be negative 6, which equals 9 plus 24, which equals negative 15. What? No. Yeah, positive 15. Sorry about that. Positive 15, what am I saying? 9 plus 24 is 33. So that's positive. So two different real roots. Let's double check this real quick. Okay, another you do. So we'll have 5x squared plus 2 root 10x plus 2 equals 0. This is already in standard form. We have x squared, x, 2, and 0. You can pause it right now, work on your own, and then play it, and you'll see me solve it. So a equals 5. B equals 2 root 10. It's just whatever's in front of the x term, and or whatever's in front of the x. And then, sorry, C is just positive 2. C equals 2. So b squared minus 4ac is our discriminant. And we'll have 2 root 10 squared minus 4 times 5, because that's a, times c, which is 2. If we're squaring this, 2 times 2 is 4. Root 10 times root 10 is just 10, minus 4 times 10. Oh, look at that. 40 minus 40, that equals 0. This means that, wait, could you see that? Yes, great. This means our discriminant equals 0, so there's one real double root. One real double root. Double rainbow.
Double rainbow. Oh my god. It's a double rainbow all the way.
Oh, ha ha ha, double. Oh. So, last note. If the discriminant of a quadratic, so if the discriminant of a quadratic is a perfect square, a perfect square, meaning if it ends up being 49 or 36 or 16. So if it's a perfect square and the quadratic has integral coefficients, meaning the coefficients aren't fractions, they're just integers, meaning the integers or the coefficients are just integers, then the quadratic will have rational roots. Then the quadratic will have rational roots. So, I'm done. The end.